This video will discuss the solution to question 38. Please consider the DAC circuit in figure 7. The DAC is ideal except for a finite but frequency independent gain A of the op-amp. About how large should A at least be so that the error in the most significant bit is not larger than 50% of VLSB. If Vref is 1 volt, R1 is 1 kilo ohm and Rf is 512 ohms. And then 8 possible answers are given. Let's first write down the given information. Vref is 1 volt, R1 is 1 kilo ohm, and the feedback resistor Rf is 512 ohms. Moreover, this is a binary DA converter, meaning that every following resistor will be twice as large as the preceding resistor. So R2 will be 2 kilo ohms, R3 will be 4 kilo ohms, and R8 as a result will be 128 kilo ohms. In this question, we are asked to assess the error in the most significant bit. That means that switch 1 is the only switch which is turned on. All other switches are directly connected to ground. With this information, we can redraw the situation as the following circuit. Because the gain of this operational amplifier is not infinite in this question, we need to assess what the potential will be at this inverting terminal. For that, we can use the basic equation of the operational amplifier. The output voltage of an operational amplifier is the gain A multiplied by the difference that is sensed between the positive terminal and the negative input terminal of the operational amplifier. In this case, the positive terminal is directly connected to ground, meaning that the output voltage is minus A times the voltage at the negative input terminal. And from that we can conclude that the voltage at the inverting terminal is minus Vout over A. With this information, we can perform nodal analysis at the inverting input node of the operational amplifier. That will yield us the following equation. We can now fill in the numeric values of Vref, R1 and Rf to get the following. Now we can use this equation to set up an expression for Vout in terms of A. We can now use this expression to assess the ideal output voltage. In other words, what would be the output voltage for the limit when A is going to infinity? Well, that would be minus 512 over 1000. The error introduced by a non-infinite op-amp gain is the difference between this real output voltage and the ideal output voltage. We can use these two expressions to set up the following error equation. In the question statement, it is said that this error may not exceed half the LSB voltage. In question 37, we found that the LSB voltage is minus 4 millivolts, so this error should not exceed minus 2 millivolts. If we now solve this inequality for A, we will get that A must exceed 385.56. Because A is a voltage gain, as shown by this expression, to convert the value from linear scale to decibel scale, we should take the 20 log 10 of this, which is equal to 51.7 decibels, which is approximately 52 decibels.